Right, which numbers do we want to see? Do you go over or have questions about?
Okay.
What else?
Get one. How are you gonna get one?
Wait. Like, that's like 1 and 2.
8, 9, 1.
I think.
Okay. So I see a lot of 1s and 2s and some 3s. So we'll do those 3.
1, 2,
1, 2,
Wait.
we're doing 1, 2, and 3. So for number 1, we have to put that into Desmos. Okay, cool. Alright, so we see the points, and then to find our line of best fit, we have to use our similar to y equals mx plus b, but we're using x1 and y1. So y1, then our squiggly line, the tilde, mx1 plus b. And that would give us our line of best fit. Use 3 decimal places, so y equals 0.891, x minus 0.087, round. And then for number 2, using number 1, find the milk consumption in 1 week of a 7-member family. So we know the family size is 7. I can type in, and that was your x column, x equals 7, and find where those 2 lines cross. And at 6.2, since all of these are to the first decimal place, that would be the milk consumption. 6.2 gallons of milk. Questions on either of those before you do 3? I mean, there's a lot of people also. Alright, a construction company charges $15 per hour for debris removal plus a one-time fee for the use of the trash dumpster of $60. How many hours of service were required if my final bill was $195? So you would need some variable, let's call that number of hours. And then we know for however many hours they use this, it was $15 per hour. And they had to pay a one-time fee for the trash dumpster. And their total was $195. So you should have had some sort of equation that looked like this and solved it. So if we divide by 15, how many hours was that? 9.
I did that, but I gotta like wait. I gotta like do it here.
Is your equation math line?
No, but I got it right.
Okay. So if your equation doesn't match mine, then you didn't. You got lucky.
No, I don't think I did.
Okay. Alright, we're going to quickly go over the SOL 6a and b. Make sure you write these answers down. All of these were finding slopes, so that means you could have used Desmos for every single one of these, put these in, and just looked at and counted the slope. But if you did the work is up here. So you can write down the work, but you could have used Desmos, and you could just write down the answers and go back and find this at a later time. So for number 1, the slope of part A was negative 3 over 2. Part B was 4/3. C was 2. Number 2, the slope was 1/2. Number 3, the slope was 1. Or the slope was negative 2. And then I'll slow down this. And then when you're ready, go on to the next page. Five was negative 4. The slope for 6 was negative 3/5. And then for SOL A.6a-b, you had to plot for number 7 and 8 2 points that would fall on the line. So you could have put this into Desmos down the line and just plotted 2 points from that line. But the 2 points I have for this one are at 0, 2, and 3, negative 2. And then at 0, 5, and 2, 3. So you can write down all the work, but you really just need the points. For 9 through 15, all of those, you could have used your y equals mx plus b, used your slider, and found these different things. So this is the actual work for this, but we needed to write the equation that passed through this point that had an x-intercept of 3. So if you were doing it algebraically, you would need to know that that ordered pair is 3, 0. Again, if you use Desmos, you wouldn't have to do all of that, but the equation that you need is y equals negative 2x plus 6. For number 10, the equation you need is y equals 4/5 x minus 3. For number 11, y equals negative 3/5 x plus 3. And then number 12, it said that was parallel, but when you did it, it actually ended up being the same line, y equals 2x plus 4. So they actually wouldn't have been parallel. And then go on to the next page. Uh, 13, 14, 15, again, just writing the equations. So 13 was your y equals negative 1/4 x plus 9. Again, all of these can be done in Desmos. 14, y equals 3x minus 17. And 15, y equals 1/5 x minus 4. Does anybody write this down? Should be writing it down as well. So the next section that is due next Monday, this is a formative, but only part of it is going to be formative because part of it we haven't learned yet. 6C through 7D. And I'm going to tell you the ones that are actually formative. 6C is formative. 7C is formative. And 7D is also formative. Because all of those can be done on Desmos, and you know what zeros and x-intercepts and y-intercepts are. So do 6C through 7D, but 6C, 7C, and 7D are the actual formative ones. You may have time to do 1 or 2 problems from this. You may want to get a sheet of paper to do your work because it's a lot and there's not a lot of space in the notes. Or you may want to write it with a dry erase marker on the desk and then transfer that to your notes. However you want to do that, do that. I'm going to talk through this process first, and then we'll do an example or 2. Maybe have that. So, before we went on break, we talked about how to factor trinomials when this a value was 1. I want to say that we did the GCF ones too. If we didn't, we'll do that here, so it's okay. And then we also talked about grouping when there's 4 terms. We're going to combine a little bit of everything we learned in this. So we still have trinomials, but this a value is going to be something other than 1. And when we see that, we're first going to look for a GCF. Is there something they each have in common? If it has one, we're going to divide that out. That could simplify it, or we may have to keep going. After that, we're going to multiply A and C. Multiply those 2 numbers together, so not the x's, but just the coefficients and the constant. Figure out what that number is. Whatever that number is, we're going to look for factors of said number. And then figure out which of those factors would add or subtract. So it's kind of similar to the a equals 1 trinomials, but a little different. And then once we get those 2 numbers, we're going to rewrite this trinomial into 4 terms, this polynomial. Taking this middle term, splitting it into those 2 new numbers, and then we factor by grouping. So it sounds like a lot, it is a lot, so we'll take that step by step. So in example 1, is there something that all 3 of these have in common? Does this have a GCF? No. Other than 1. I'm just going to put that off to the side just so we remember that we checked that first. Always check for a GCF first. It will make your life easier, especially if you see big numbers. Then we're going to multiply 2 and 3.
So we're always going to multiply the first number?
Yep. To get 6. So then we're looking for 2 numbers that multiply to be 6. What are some factors of 6? 3 and 2, and 1 and 6. Of those, which ones would add to be 5?
3 and 2.
3 and 2. So we're going to take this middle term, we're going to split it into these 2 new terms. The first and the last term are going to stay the same. So we're going to write 2x squared plus, it doesn't matter which order you put them, plus 3x, since this middle term had an x, plus 2x, and then plus the 3 in the end. If you wanted to put them with each other, like this one has a 2, so maybe you want to put the 2x here, that's fine. It doesn't matter, the order. And then once you have 4 terms, now we're factoring by grouping. So as a reminder, we split that down the middle. And we're looking for a GCF on this side. What do these two have in common?
X.
X. So we are dividing both of these by x, but not at the same time because we don't want to get rid of it.
Wait, they both have 2x.
So do they both have 2 x's?
Oh, no.
No, only one does. So if we divide x out of both, what's left?
2x.
Plus.
3.
And then what do these last two have in common? 1. If nothing, always a 1. That means the inside's going to be the same. Remember that with factoring by grouping, you want those inside factors to be the same.
Wait, so shouldn't that be minus 3?
You want it to be the exact same. So if these are the same, that's one of your factors. And then everything on the outside is your second factor. And then to check yourself, you could distribute this back out, and you should get this. So I'm going to do that really quickly off to the side.
Do you have to write that?
No. So if I were to distribute this back out, x times 2x is what? 2x squared. X times 3, 1 times 2x, and 1 times 3. And then if I combine my like terms, we get that same thing. So this is a check yourself method. If you do that and you don't get the same thing, you put a negative somewhere where it shouldn't have been, or you forgot to bring down a number, or you didn't factor out the UCF correctly. What questions do we have on this process? Okay, let's try example 2. Is there a GCF? No. Other than 1, I'm just going to put that off to the side. So then multiply the first number and the last to get 30, okay? And then we're looking for 2 numbers that multiply to be 30, but add or subtract to be negative 17. Okay, so factors, 5 and 6. What are some others?
50.
30. 30 and 10 and 3. 15 and 2. Okay, so of those, which ones could we multiply together to get positive 30, but add or subtract together to get negative 17? How could we make them negative? How could we make it negative 17? Yes, then we both need to be negative. So then rewrite it. First and the last stay the same. Since I know 15 and 5, I can divide out of 5. I'm going to put the 15 with it, but if you wanted to switch them, it would work the same way. I was trying to do this color coded so you can see what's happening. And then split the middle. What could we divide out of those first two? 5 and m. What would be left? M. 3. What could we divide out of the last two?
2.
-2. So, I don't believe I said this, but anytime the first term is a negative, divide out that negative. What would be left? N minus 3, and then what would your two factors be?
N minus 3 and 5 and minus 2.
It does not matter which one you put first, as long as you have them both. Any questions so far? Okay. So we'll do more of these tomorrow. Reminder that you have a Delta Math on this that is due Friday. That is formative. You have your SOL practice for next Monday. That parts of it are formative. And if you haven't started working on your JLabs, you need to be working on those. So I'll give you the rest of class today to work on any of those things.